8.4 normal approximation to binomial distribution. Now, when we have a binomial distribution, failure and success, right? The binomial distribution, we have P and we have Q. Remember that P is the probability of success and Q is failure, which is 1 minus P, right? Q is 1 minus P. This method, you can use it if you can approximate this to be normal distribution. Just remind you, normal distribution is like this curve, right? In the middle of that is mu. Here gonna be your value of the x. And when you convert this one to the z-score, the mu turn into 0. And you can use the z-score value to find the area under the graph. Okay, let's just go. Mu here is NP. N is the number of the trial that you have, and P is the probability of the success. And sigma, standard deviation, is square root of NPQ. If the N and P, NP and NQ are bigger than 5, you can approximate this binomial distribution to be normal. Now let's just do an example. A bank found that 24% of its loan to new small business become delinquent if 200 small businesses were selected. So your N is 200, P is 0.24. 24 divided by 100. So what is the probability that at least 60 of them are delinquent? Probably 60 of them delinquent means P when the X is greater than 60. Since 60 is included, we need to say X greater than 59.5. Make sure 60 is included in that interval. Make sure this could be described by normal distribution. NP and NQ should be greater than 5. So NP, N is 200, P is 0.24, 48 is greater than 5. Now NQ, Q, you know how to find Q. Q, you can find it as 1 minus P. 1 minus 0.24 give you 0.76. So this is that. So it's NQ. N is 200, Q is 0.76, 150, which is greater than 5. So we can use the normal distribution for that. So mu here, you guys, you know that we did discuss that all here. Mu is NP. This 200 multiplied 0.24 is your mu, and sigma is 6 NPQ square root. Square root of 200 is 0.24, 0.76 is 6.04. So since I want to find the probability when the X is greater than 59.6, right? You need to convert this X into Z. I hope you remember that the z-score is equal to X minus mu divided by sigma. Your X here is 59.5. Your mu is 48. Sigma, we got it to be 6.04. So this is give you 1.90. So X greater than 59.5 is Z, converted that to Z. Z greater than 1.9. Now, we look at the table. This is for z-score to find for 1.9. Let me just erase this ones. This positive 1.9. Just going to the positive value. Here is positive value. Here's 1.9 there, okay, which is 0.97. So these 0.9713 is the area less than that, right? But I want that to have for greater. So since all area here is 1, so above this Z, it is 1 minus the area is given. This area given is for this one. I'm just gonna bring it up again. It is for 1.9 is 0.97 approximately. 0.97. 0.97. 9713. So you have to say 1 minus that, because this one is just, you have that. For this Z score, so imagine that the Z score is 1.9, right? 1.9. This is my Z. This area here, it is what? It's a different color. Is 0.9713 as we have from that. But I want to find this area, the green area. I'm just put it out as a green. Like you do, because total area is 1. This area going to be 1.1 minus 0.9713, right? Make sure I have I have the right number here. For 1, yes, 0.9713, good. Now let me erase this. So the answer, the probability that x is greater than 59.5 is 0.029, or multiplied by 100 is 2.9%. Okay, so let me just go to the next question. Okay. There we go. Okay, next question. Coca-Cola, a soft drink company, knows that it has a 42% market share in one region of the province. Its marketing department conducts a blind test of 70. 70 is your N. At a local mall, what is the probability that fewer than 25 people will choose? So X less than 25. Since 25 is included, say probability of X is less than 24.5. Now 42% is your P success, and Q is 1 minus P, right? Which is 58%. So we find NP and Q, both of them is greater than 5, so we can use normal distribution. Mu, the mean value is NP, and we have a 70P, we have it, 9.4, and sigma standard deviation is NPQ square root, so we got it to be 4.7, so 4.13. Now, here we have X again. We need to convert X to the Z. You know, Z is X minus mu divided by sigma. Here is my X is 24.5 minus mu, which is 29.4 divided by sigma, which is 4.13. You get that to be negative 1.19. So this is your Z score. Now convert everything to Z score is adjustment to negative 1.19. You look at the table, negative 1.19. So we go to the negative value, 1.1 here is, now you go to the 9. 1.1 is here. Here I need to go here. This is my last digit, 9. So it goes that 1.9, 1.19. So that would be the number, 0.117. Okay. So since this is less than that, so this is less than area, right? Give me this area less than that, so I don't need to do anything further. That's the probability, 0.117, or approximately 11.7%, which is the same as 12%. So round it to the 12%. B, what is the probability that exactly 25 people will be chosen? So when you say 25 people, means the 25 is between 24.5 and 25.5. So we convert both of these two numbers to the Z score according to that. And when you got your Z, and you want to find a trap area between the two z's. See, this is 2z that you have. Let's say most of them is negative, doesn't matter. Let's say here is negative 1.19 for your z, and here is negative 0.94. So to find a trap area between them, you find a trap area before 0.94. I just denote that by here, by a green, and you minus it by an area less than that, right? And if you minus the green area minus that one, you will get the trap area between these two numbers. Therefore, for P of this is less than the 0.94, the area less than that, minus P of the area less than negative 1.19. Most of these two numbers, you can find it from the z-score table, and you find that these two numbers, you minus each other, and that would be the result, which is 5.7% or approximately 6%. Okay, for practice, you can practice question number 4, 5, 6, and 8.